Good afternoon, dear students. Today we are going to continue with 8.2 collision theory. These are the learning outcomes we discover under the collision theory. What is collision theory? In a chemical reaction, molecules of reactants collide with each other to form product. However, not all collisions able to form product. This can be explained by the collision theory. The collision theory is based on the ideas that molecules of reactants must collide in order to form products. Products are formed only when effective collisions between molecules occur. What is effective collisions? Not all collisions between reactant molecules are effective collisions. A collision is an effective collision when the colliding molecules have a total kinetic energy equal to or greater than activation energy. The molecules must collide in correct orientation. Activation energy is the minimum energy required for effective collisions to occur to initiate a chemical reaction. The activation energy may be gained through collisions of molecules and used to break the bonds between atoms of reactants. Then these atoms will form new bonds in the product. The orientation of collisions means that collision of molecules occurs at the correct angle or manner that favors the formation of products. For example, HI molecules decomposes to form hydrogen gas and hydrogen gas. Iodine gas and hydrogen gas. Imagine these two molecules are placed vertically with hydrogen atom on the top, and when they decompose, they produces hydrogen gas and iodine gas respectively. That is known as effective collision because the reacting molecules, that is the HI, are positioned in a correct orientation with hydrogen atom on top and iodine atom at the bottom. However, it can be ineffective collision if both molecules are placed vertically, but in one molecule, hydrogen atom is at the top and in another molecule, hydrogen is at bottom. Although collision can take place here, but the orientation is incorrect, that leads to ineffective collision. That means no reaction occurs. Next is transition state theory. Explains the activation energy as the energy required by reacting molecules or reactant molecules to form an activated complex. An activated complex is temporary species formed by the reactant molecules as a result of collision before they form the products. The transitions theory can be explained using the energy profile diagram. This is for exothermic reaction, where the energy level of reactant higher than the product and the enthalpy will be negative. So you can see activated complex is at the top of the peak, where this is known as the transition state theory. Similarly, for the endothermic reaction, energy level of reactant is lower than product. That means our enthalpy of reaction is positive, but at the top of the peak is activated complex, which follows the transition state theory. The activated complex or transition state, an intermediate state that lies between reactant and product, form temporarily in an effective collision where reactants molecules achieve the activation energy. It is unstable. High energy species can either form product or reform the reactant, meaning to say at activated complex the species is unstable. It can either fall back to reactant or proceed to become a product. Okay, it can either form product or reform reactants in which old bonds of the reactants are partially broken and new bonds of the products are partially formed. This is the diagram representation. Imagine hydrogen gas and iodine gas both as reactants. Therefore, our activated complex looks like what they show in the diagram. Students can see the blue color dotted line is partially bond being broken between hydrogen gas and iodine gas, while the red dotted line is partially new bond formed between hydrogen and iodine atom, which leads to hydrogen iodide. And finally, after they drop from the activated complex to the product state, we will get the product HI. This is a diagram representation of transition state theory and activated complex. One thing student must take note is at activated complex, both bonds that being broken and being formed are temporarily formed. Okay, this is energy profile diagram representation. Students can see bond breaking and bond forming, and both are, as I said, temporarily formed. So meaning to say, if it falls on your right hand side, you get 2HI as the product. It also can fall on the left hand side to return back as the reactants of hydrogen gas and iodine gas. Thank you.